Hi guys, subscribe our channel Science World and hit that bell button so that whenever we upload a video, you get the notification. Today's topic is Theory of Interference, Young's double slit experiment. So for this experiment, we took a monochromatic light S. This monochromatic light is passed through two slits S1 and S2 and is made to form interference pattern on the screen S dash. Now let the light passing through S1 and S2 be formed at any point P on the screen S dash. Let the ray passing from S1 to P and its distance be x1 and the distance of the ray passing from S2 to P be x2. Now let C dash be the midpoint of S1 and S2 and it is produced at C on the screen S dash. Let D be the distance between both the screens containing the interference pattern and the two slits, and D be the distance between the two slits. Young's performed this experiment to prove interference phenomenon. Now here, as I told, S is the monochromatic light, S1 and S2 are two fine slits, D is the distance between the two slits, and capital T is the distance between the slit and the screen. C is the midpoint of the screen. Now let P be the point on the screen at a distance x from the point C. Here let P be the point on the screen at a distance x from the point C, where we will study interference pattern. Okay. Now let S1E be drawn perpendicular to S2. Let S1E be drawn perpendicular to S2P. Let S1E be drawn perpendicular to S2P. Now let S2 S1E, this angle be named as theta. Now we see, since S2 S1E and C dash C, since these triangles are congruent, so we can write angle S2 S1E equal to angle PC dash C, that is equal to, we can write theta. Now in triangle S1 S2E, now in triangle S1 S2E we get sin theta, whose formula is sin theta equal to perpendicular by base. Now here the perpendicular is S2E and the base is S1 S2, since this is the angle. So we get sine theta is equal to perpendicular S2E by base S1 S2. We get sine theta is equal to S2E by S1 S2. Now again, in triangle PCC dash, PCC dash, in this triangle we get tan theta, as we proved earlier that sine angle S2 S1E is equal to angle PC dash C is equal to theta. So we get PC dash C is also angle theta. Now tan theta, as we know the formula, tan theta is equal to perpendicular by base. So here we will get tan theta is equal to PC by C dash. Again from here we get PC is equal to X and C dash is equal to the distance D. Also we can write in the above equation S1 S2. S1 and S2, since we can write D here, small d, because it is the distance between the two slits. So we can again derive it as S2E by small d. Now if theta is very small, then sine theta is similar to theta and tan theta is also similar to theta. Therefore we get sine theta is equal to tan theta. So from this we can write sine theta, that is S2E by small d, tan theta, that is X by d. This both the equations are equal. So we can write S2E by small d, that is equal to X by capital D. Now again from here we get S2E is equal to small d into X by capital D, that is path difference between the waves at P. Therefore delta, which we will say as the symbol of path difference, which is equal to S2P minus S1P. Now it is S2P minus S1P, which we can assume as S2E, that is equal to S2E. Again S2E is equal to D into X by capital D. We can write it as X into small d by capital D. Therefore path difference is equal to X into small d by capital D. So we know that the nature of the fringes at P will depend on the path difference. Now we will find the fringe width for this path difference. Now for constructive interference. If the path difference is, say, even multiple of half of wavelength, then constructive interference will form. That is, if delta is equal to twice n lambda by 2, where we can take n is equal to any integer 0, 1, 2 simultaneously. Now, as we got the path difference is x into small d by capital D and also twice n lambda by 2, so we can derive x into small d by capital D is equal to twice n lambda by 2, where we can again derive x equal to twice n capital D by small d into lambda by 2. Now, when n is equal to 0, then we'll get, now since n is equal to 0, we can assume it as xn. We can write as x0 or x0 is equal to, now since n is 0, so here we get the sum as 0, because any number multiplied by 0 is always a 0, and since n is 0, we get x0 is equal to 0. Now for n is equal to 1, we get x1 is equal to lambda capital D by small d. As we change this n by 1, we can cut off the 2 here, then we can get lambda capital D by small d. Now when n is equal to 2, then we get x2 is equal to twice lambda capital D by small d. So here we can see the whole sum comes in a certain pattern. Now we can write, when we put n is equal to n, then xn will get twice n d by small d into lambda by 2. So here we got x0 is equal to 0, which is the central bright fringe. Now x1 is equal to lambda capital D by small d, which is the first bright fringe. Then x2 is equal to twice lambda capital D by small d, which is the second bright fringe, and so on. So from this we can conclude that fringe width beta, that is x1 minus x2, the difference between two consecutive bright fringe, is equal to lambda capital D by small d minus 0, that is equal to lambda capital D by small d. Now for destructive interference. Now, if the path difference is odd multiple of half of the wavelength, then we get destructive interference. So here we can directly write fringe width or the path difference delta is equal to twice n minus 1 lambda by 2, where n is equal to 1, 2, 3. We cannot take n as 0, as n is already 0 in bright fringe. Now when we put n is equal to 1, 2, 3, the same as we will get. For the path difference, we can take x into small d by capital D is equal to twice n minus 1 lambda by 2. Now same we can solve it for x. We'll get x is equal to twice n minus 1 capital D by small d into lambda by 2. Now when we put n is equal to 1, then x is equal to, now if we put n equal to 1, we get 2 ones are 2 minus 1, so it is 1. So we get here capital D by small d into lambda by 2. Now when we put n equal to 2, then x2 is equal to 2 into 2 4 minus 1 3. 3 into capital D by small d into lambda by 2. When we put n equal to 3, then x3 is equal to 2 3 is 6 minus 1 5. 5 into capital D by small d into lambda by 2. Similarly, when we go on and put n is equal to n, then we get xn is equal to twice n minus 1 capital D by small d into lambda by 2. Now here for n is equal to 1, we get the first dark fringe. It is not bright fringe, but it is dark fringe. Then for n is equal to 2, we get the second dark fringe, and so on. Now the fringe width here, beta, that is x2 minus x1 is equal to the same 3 into capital D by small d lambda by 2 minus d by capital D by small d into lambda by 2. So we get lambda capital D by small d, which is the fringe width beta. So this is Young's double slit experiment.